In this video, we're going to evaluate the integral of 1 over the square root of x squared minus 9. And this is a special type of integral that involves a certain substitution. So let's look at the different forms that we can have. These special substitutions are going to involve the sine function, the secant function, and the tangent function. Cosine can also be used and so forth, but these are the main ones. So you draw yourself a right triangle. We'll name the angle, the acute angle here, theta. And for sine, the triangle involving sine, it'll be sine of theta will equal to the opposite over the hypotenuse. And using the Pythagorean theorem, you can put this triangle together. These will be the sides, a, u, and the square root of a squared minus u squared. And the one we're going to use in this substitution involves the secant. So secant will be defined, secant of theta will equal to u over a, where u could be a function of x, or it could just be plain old x. So secant, hypotenuse over the adjacent, get u over a, and you can see that hypotenuse then would be length u, the adjacent side would be a, and the opposite side would be the square root of a of u squared minus a squared. And there's a one involving tangent. These are the main three forms. Hypotenuse in this case is the square root of u squared plus a squared. Opposite side is u, the adjacent side is a, and tangent of the angle is given by opposite side u over the adjacent side. And here's your substitution for all of them. Let u equal to a sine theta, let u equal to a secant theta. This is the one we're going to be using for this problem. Or let u equal to a tangent theta. Here we have it. So in this one, in case of, instead of u squared, it's x squared. No problem, just use it the way it is. So here's what we're going to have then. Secant theta will be x over 3, the hypotenuse over the adjacent. And if I solve this for x, I get x is equal to 3 secant theta. Find the differential here. Dx will equal to derivative of secant, be secant theta, tangent theta, d theta. And of course, you have your constant. And now the radical, remember, it's the square root of x squared minus 9. So I put the value of x there is 3 secant theta. Square it, we get, so this is right here, this will give me a 9. Because I'm squaring the x or squaring the 3 secant theta. This will be 9 secant squared theta minus 9. And if I take out a factor of 9, remember we're under the radical here, be 9 secant squared theta minus 1 under the radical. So if we break it outside the radical, the square root of 9 would be 3. That's how we get this. And then there's an identity that tells me that secant squared theta minus 1, secant squared theta minus 1 is tangent squared theta. But we're under the radical, so that's got to give me the square root of tangent squared would give me tangent theta. And of course, you have the square root of 9 is 3. So those are the substitutions we're going to use then. X, wherever there's an x, replace it by 3 secant theta. The dx will be given by this right there. And then the radical expression that we saw will be 3 tangent theta. Let's start right here. We have all the substitutions right there. And it's going to be the integral. And then the dx will be 3 secant theta, tangent theta. And then it's d theta. And this radical here, based on these calculations here, is going to be 3 tangent theta. So in this case, we're changing the variable of the integral from x to theta. So notice here, the tangent theta here, the tangent theta here, divide out. 3 and the 3 divide out. And what I have left then for the integral is secant theta, d theta. And this integral comes out quite a bit in other problems. So this is one again, I think I mentioned it before. Most instructors will expect you to memorize this formula. What is the integral of secant theta, d theta? Well, let's see, natural log of absolute secant theta plus tangent theta plus the constant of integration. So if this came up in a certain problem, other problem you're doing, you could just write it out this way. If the variable is already in theta. But remember, in our case, the original variable was x. So the only thing we have to do now is we have to rewrite this in terms of the original variable. And this is where you get where you use the triangle. It's the absolute value here of secant of theta. How do we get secant of theta? Well, you go to the triangle. Here it is. Make sure you construct this triangle given the information from the problem. So secant is the hypotenuse over the adjacent. That's x over 3. So for secant theta here, x over 3. And it's plus. You want tangent of theta in terms of the original variable. So that's what we have here. The triangle is constructed from the original variable. Tangent of the angle is opposite over the adjacent. So you can write this as square root x squared minus 9 over 3. And now if you work this from some textbook, they're not going to give you this answer. They're going to give you the answer as the natural log of absolute x plus the square root of x squared minus 9. So you're going to wonder what happened. Well, what they did is this. They have the same denominator here, so they wrote it this way. Natural log of absolute x plus the square root of x squared minus 9 over 3. But then what they did is they said, okay, we have the log of a fraction, so this is going to be equal to the log of the numerator, which is x, plus the square root of x squared minus 9. And then it's minus the log of absolute 3, well, that's so just going to be 3, plus the constant of integration. So what I'm going to do is I'm going to call, so you can see what's happening here. This obviously say constant C1. This is still C1. And then right here, this is just a constant. There's no variable here. So what they do is they put these together. Say minus ln of 3 is a constant and C1 is a constant. Let's put them together. So I can remove this and the C1 is gone. And the final answer that can be submitted is plus the constant C. The C1 and the ln of 3 are included together. So you'll see the final answer as ln, or natural log of absolute value of x plus the square root of x squared minus 9 plus the constant of integration. Thanks for watching. We'll see you next time.